Okay, so essentially we're just, again, we're simplifying. What we're hoping to get is eventually a constant, a singular function, or a power of a singular function. So essentially let's perform the operations and see what happens. So in this case, the operation is to basically do a distribution. So I have cotangent of x times tangent of x plus cotangent of x secant of x. All right, and we know that cotangent and tangent, they're basically reciprocals of each other, right? So that's 1 over tangent of x times tangent of x. So what we get here is 1 plus, how about I go ahead and convert these to their sines and cosines? This is basically cosine of x, sine of x, right, times 1 over cosine of x. Alrighty, and so what we end up with here is the cosines cancel out. All right, and we end up with 1 over sine of x. So we have 1 plus, I guess that's cosecant of x at this location. And so here that's about as far as we can take that one. All right, we're not really a constant, and we're not really a singular function. We're kind of a combination of both, a constant and a singular function. So we perform the distribution, and then in this case I use the reciprocal identity to get 1. There's my constant. On this side, I changed to sines and cosines. Let me make sure I did that right. Cosines went away. What's left is a cosecant. So I have one argument. I have one cosecant. I have a constant. Putting them together, we've simplified that side as much as we possibly could by doing the operation that was shown. Next one, we're asked to do a division. So a lot going on here, but probably the best thing to do is let's start this off by just rewriting everything in terms of its sines and cosines. So upstairs I have 1 over sine and 1 over cosine, and downstairs I've got cosine over sine. So when we divide by a fraction, we multiply by a reciprocal. So we basically have 1 over sine x cosine x, and then multiplying by a reciprocal, we get sine x over cosine x. Okay, so we reciprocal that function. See that the sines cancel out, and we're left with 1 over cosine squared x. Of course, using the reciprocal identity, that's secant of squared x. So we were able to get the job done there. So we were able to rewrite that by performing my division and rewriting in terms of sines and cosines using my reciprocal and quotient identities. I was able to rewrite this as just one singular function to a power, in this case secant squared. So just good news for us. On this next one, again, lots of ways we can do this, but what I'm seeing right away, right, cosecant of x and sine, they're reciprocals of each other. Right, so this is 1 over sine x times sine x. So we basically have 1 over cosecant squared minus 1. And cosecant squared, well, this is secant squared x minus 1. And looking real close like this, a couple ways we can see this. We know that tangent squared x plus 1 is equal to secant squared. So if I replace the secant squared with that, what we get is tangent squared x plus 1 minus the 1 that was already there. The 1's cancel out, and what's left is tangent squared x. So again, we were able to rewrite this as a singular function to a single power. So in the whole page here, what I basically did, right, is I performed the indicated operations, whether we were adding fractions or subtracting them, whether I was performing a multiplication, right, whether I was performing a division, and here I was doing a division and a subtraction, right, and this seeing identities, using identities, converting things to sines and cosines, a lot of algebra work, a lot of math work, a lot of multiplication, and seeing those identities and using identities and seeing them in different ways, right? That was our cosine squared plus sine squared written differently. I had an opportunity to use sine squared here. So just seeing those. I saw tangent squared plus 1 and cotangent squared plus 1. So seeing identity and using an identity. And of course, watching these, one thing, I've been doing this for a long time. I kind of know some of the nuances, know where to start, know where to end and change things. You guys only get that good by practicing. So make sure you practice, make sure you work with this, give it your best shots, talk to your neighbors, right? Jump on Canvas and compare and contrast ideas, because we will learn a lot from each other, right? And it'll give me an opportunity to tell you good start, bad start, reconsider this. So keep practicing. More algebra coming soon.